Okay, in this problem you have a 35-gram bullet. It strikes a 5 kilogram stationary piece of lumber and embeds itself in the wood. The piece of lumber and the bullet fly off together at 8.6 meters per second. What was the speed of the bullet before it struck the lumber? Define the bullet and the wood as a system. We can go ahead and start with our givens. We're going to let the bullet be object number 1, and then we're going to let the piece of lumber be object number 2 then. Alright, so first we're going to start with our givens. So we're given, looks like the mass. The mass of the bullet is in grams. And in physics, we use kilograms for the SI unit. So whenever you see grams, automatically convert to kilograms. So this is going to be our mass 1. It's in kilograms. So we move the decimal spot or the decimal dot 3 spots to the left. So it's going to end up being 0.035 kilograms. It strikes a piece of lumber that is mass 2. So our mass 2 is going to be 5 kilograms. And the piece of lumber is stationary. So remember, when it says stationary, this implies that the object is not moving. So its velocity at this point is going to be 0 meters per second then. And since this is the beginning before the collision of the bullet and the lumber, this is the initial velocity of the lumber. So the initial velocity of object 2, which is the lumber, is going to be 0 meters per second then. Continuing forward, we see that the piece of lumber and the bullet fly off together at 8.6 meters per second then. So that means that the final velocity, which is the velocity after they collide, is going to be 8.6 meters per second. Because they are stuck together, this tells you what type of collision it is and which equation you're going to use, which we'll show on the next slide then. What's our unknown? Well, the question's asking what was the speed of the bullet before it struck the lumber. So I just need the magnitude of the velocity of the bullet before it struck the lumber then. For the unknown, it's going to be the initial velocity of object number 1. So in this problem, I have a bullet that becomes embedded in a block of wood. And once it becomes embedded, it will travel with the block of wood with a velocity of 8.6 meters per second. So my equation, I'll go ahead and use the one with mass 1 plus mass 2. So I'll rewrite my equation with mass 1 times velocity of the bullet, initial, plus mass 2 times velocity of the block, initial, is equal to the two masses added together multiplied by the final velocity then. I need to solve for the initial velocity of object 1, the bullet. So to isolate this, I'll go ahead and rewrite my equation one more time. Mass 1 times velocity 1 initial plus mass 2 times velocity 2 initial is equal to the two masses added together times final velocity. So I'll go ahead and subtract this term out because this term is added with the velocity 1 initial. So I'll go ahead and subtract mass 2 times velocity 2 initial minus on both sides, mass 2 times velocity 2 initial. This term will cross out. So on my left-hand side, I will just be left with mass 1 times velocity 1 initial is equal to this term, which is mass 1 plus mass 2 times final velocity minus mass 2 velocity 2 initial. Because there's no terms I can combine at this moment, this is what I'm left with then. So the next step, to get the velocity by itself, I have to get rid of this mass 1. So I'm going to divide both sides by m1 then. So on the left side, this term and this term will cancel. I'll be left with initial velocity of object 1 is equal to, now there's nothing I can cancel out here. There's nothing I can shorten. So I'm going to just be left with this whole equation here. So mass 1 plus mass 2 times final velocity minus mass 2 velocity 2 initial all over mass 1. So now I'll go ahead and substitute the values into the equation and solve. I'm going to go ahead and rewrite my equation. I have velocity of object 1 initial is equal to the mass 1 plus mass 2 times final velocity minus mass 2 velocity 2 initial all over mass 1. So substituting my values into the equation, mass 1 is the bullet, so I'm going to plug in 0.035 plus the mass of the block, which is 5 kilograms, times the final velocity, which is 8.6 meters per second, minus the mass of the block, which is 5 kilograms, but the initial velocity of the block turns out to be 0, all over mass of the bullet, which is 0.035. Now looking at my equation, I notice that 5 times 0, this is going to be equal to 0, so this term drops out. So I'm going to end up with 5 plus 0.035 or 5.035 times 8.6 divided all by 0.035. If I plug this all into the calculator, I should get the value 1,237.17. Let's not forget the units. Since I'm dealing with velocity, my units are meters per second then. Now we got the initial velocity of the bullet to be 1,237.17 meters per second. So to double check our answer, we're going to go ahead and analyze the sign. It is a positive value, so it means that the initial velocity of the bullet is traveling to the right, just as the bullet and the block after the collision. It makes sense that the bullet is traveling the same direction after the collision, so it should be a positive value. Check to make sure, is it too small, too big? In this case, 1,237.17 meters per second seems rather large, but it makes sense because it's a bullet. So as long as it's not too small, like 5 meters per second, and it's not too big, like 1,000,000 meters per second, your value will then check out then. So in this case, 1,237.17 meters per second checks out.